Number 6.
So, again, when we were last speaking, we had the question raised as to whether or not there could be a dialogue. Would you like to rephrase your question?
Sure, I'd be happy to. So in the slide, you had a price and certain numbers that were attributed to, I don't know what those numbers represented, the 1s and 4s. I don't know if they were feasibility numbers or
how difficult it is.
How difficult it was to do. And there were some different discussions about just how difficult it was. My first question had to do with the cost, which I think was $332 million.
I'll put that slide up for you.
For that, I think there was some disagreement, or I mean, maybe disagreement is too strong a word. I mean, I do not think that it was the $10 billion that Ms. Espinola suggested. That would be, wow, too scary for words. But I'd like to know, between Ms. Keto and Mr. McGowan, what you think that is and how you guys arrived at that, and what do you think that, what are the challenges in doing that?
Sure. First of all, let me tell you a little bit about how we do cost estimations. The fortunate part for us is that we've done a lot of removal actions on site. We did a lot of studies, so we kind of have an idea of how much things cost. And now that we do not only chemical, but we do radiological, we can always compare on other previous past things of how much, certain cubic yardage, if you bring it out to a unit, would cost. So your first question is, geez, you're just removing some material. It can't be that much. Well, in one sense, it's kind of true. So if you just talk about the landfill mass, we're talking about, roughly, I'm going to be estimating about 440,000 cubic yards of material, approximately. But remember, you have a landfill. You have stuff in a landfill, but you also have material on top. You can't get to the material in the landfill until you get to the stuff on top, right? So that stuff on top, it's going to be approximately 400 cubic yards of material. Okay? Doesn't mean that it's going to be something that you have to clean up, but you definitely still have to sample it and make sure that it decide where it's going to go, either back into the hole or offsite. And then you have the stuff on the bottom. You have to make sure that it's completely clean.
So Melanie, once again, the numbers are, there's 400
about 400,000 cubic yards of clean on top.
On top?
And about 430, 473, I'm sorry. 473,000 cubic yards.
Of the landfill itself?
Of the landfill itself, and then about 130,000, right?
Yeah, 142,000.
Of material underneath the landfill material. So if you add everything up, you're looking at about 1 million. Right. 1 million cubic yards of soil, which is a lot. And now these are just numbers to you guys, just kind of give you an idea of comparison. We've obviously been doing a lot of work on Hunters Point for a long time. If you were to add all our components of what we've done, from our tech res to our sewer removal, I would guesstimate it probably equates to about 250,000 cubic yards of material. So 1 million is a lot. Now, I'm not saying all of that is dirty, has to be cleaned up, but it's still, you still have to move that, and that costs money. So that's number one. Number two, you have to, the biggest component of that cost is going to be your transportation and disposal. So if you want to just break down your $330 million cost that we have up there, I would say the actual excavation and the radiological surveys and your groundwater, is probably about 35% of that. About 60% of that's going to be your transportation and disposal of that. That's where your big portion comes out. Doug, did I miss anything?
Yeah, no, that covers it. I mean, basically the excavation process it involves a lot because, as Melanie mentioned, there is a lot of solid waste there. There's a lot of soil that was placed on top of it, both in the mid-1970s when the landfill was first closed, and then also, in subsequent actions by the Navy, in particular, interim cap that was placed in 2000 and into early 2001. And then this waste, it extends as deep as 13 feet below mean sea level. So if you think the average surface elevation of the landfill is, approximately 15 feet above mean sea level, you're talking, something on the order of a 30-foot pit right against the bay. So it would involve some pretty significant engineering to build essentially a containment around that entire excavation. Think about unfortunately, the excavation of the World Trade Center, that big bathtub You know, you'd be talking about something on that magnitude and scale as far as depth and size, and that involves a lot of control of groundwater as well as the bay. There's cost associated with that. There's significant worker safety risks associated with that, and then just physically dealing with that volume of soil, going through the radiological screening process, which for those of you who are familiar with what's been done in past removal actions, is a fairly painstaking process. It consists of a surface screen to identify potential radioactivity, removal of any anomalies that are found, any contamination above their trigger levels. And then once that soil is excavated, it goes through a secondary screening process to also look for any potential radioactivity. And what that does is it slows the production rate down. So if you're at a normal site with no contamination, you have heavy equipment out there, you can dig pretty fast through that material and do what you need to do with it. When you're looking for radioactivity, plus there's also chemical contamination that needs to be accounted for, it really slows down the process. And that's what the Navy has been, those procedures have been well established for these interim removal actions that the Navy's been performing over the last handful of years. And so our estimates took into account all those procedures. And so, as Melanie said, the total cost for excavation, including the labor and heavy equipment to excavate the soil, the screening process, all the engineering controls that would be required to control the water, is roughly around 30% of that 332 million, and about 65% is the transportation and disposal, with the remaining amount being backfill and restoration of the site after excavation is complete. So that's essentially the way it breaks down cost estimate wise. As far as how difficult it is to implement, I mean, the volume of soil is just one aspect of it. Again, the depth of excavation, the proximity to the bay, and just the sheer magnitude of this excavation. Our estimates are that it would take approximately 4 years of continuous construction activity.
That was my question.
Of digging, screening, shipping this material off-site continually, nonstop for 4 years straight. So that's, trucks bringing in clean backfill through the community. Our estimate actually had planned to rehabilitate some of the rail lines on the base to ship the contaminated material off, therefore minimizing the amount of truck traffic. But still, just the sheer volume of industrial activity is pretty significant. So that gets to implementability as well as some of the short-term risks to the local community. And those are factors that the Navy needs to consider in conjunction with cost as well as the long-term effectiveness of digging up the landfill, which of course would have more benefit than leaving it in place. But all of those factors need to be considered all together, and that's what our analysis did.
Well, yeah, I think that's the big trade-off, is that